Dear Chairman and dear colleagues, my name is Viviána and I am a PhD student at the Eötvös Loránd University. And today I'm going to talk about the surface velocity measure on glaciers in the Southern Patagonian Ice Field. First, a little bit about my motivation and my goals. So what does the velocity of a glacier tell us? The change of cryosphere, what is really fast nowadays, strongly influences global climatic processes like the water level change. And the velocity of glaciers responds really quickly to changes in any climatic parameter like the precipitation or the air temperature. So examining the velocity of glaciers, we can estimate the extent of the environmental change. The method that I am using for this is called the tracking method. And the exact method that we used in this study is publicated by Tuckett and his colleagues in 2019. This method previously used only in polar areas, so we had the opportunity to try it in another area for the first time. And this method is based on Sentinel-1 SAR images, and we calculate the velocity for 12-day periods because of the satellite way. And the speciality of this method that it's using a feature and speckle tracking at the same time. Feature and speckle tracking making a cross correlation between two satellite images. The difference that the feature tracking identifies landmarks, objects on the fields like glacier craves or some sediment on the surface, and measure these points displacement relative to each other. But speckle tracking can identify physical parameters like the water content in the ice and measure these points displacement relative to each other. And on the right side, you can see one of my velocity map. And if we go closer, you can see this colorful part of the image, which is the satellite image cover. And the colors show us the velocity of the glaciers, and you can also see some narrow arrows on the glaciers, which show the ice flow way. My study area, how I already mentioned, is the Southern Patagonian Ice Field. This is the second largest glacier area in the Southern Hemisphere, and so we can find here a lot of large and fast-moving glaciers. I sampled almost 1,000 areas at the northern part of the ice field and at the southern part of the ice field. And you can see these sampled areas. These black squares are these areas. And I examining the velocity and other parameters in these square regions. And about the results, today I'm going to talk only about the velocity of the glacier Horhemond because I don't have time to talk about all the glaciers. But this is one of the most special glacier in this area because this is the northernmost glacier on the ice field. So its aspect is northern, not eastern or western, like all the other glaciers on the ice field. And its accumulation area has a really special shape, which you can see here on the right side on the figure. It has got a rounded shape accumulation area, not a straight flow line. And its velocity is one of the fastest and most variable based on previous observation, which was taken by Maginot and Rignot in 2015. And the period that I'm going to show you now is cover one full year from December 2019 to November 2020. But how I mentioned, it's not covered the full months, just 12 days in the middle of the months because of the method. And here you can see the results, which is important that Horhemond 1 sampled area is at the front of the glacier, how you can see here on the picture, and the Horhemond 21 sampled area is at the accumulation zone of the glacier. And here you can see the measured velocity through the whole year in the sampled areas. It's between 100 meters per year and almost 5,000 meters per year. And I wanted to know the relationship between the velocity and the topography. So I calculated some topographic parameters in the sampled areas based on 30-meter resolution SRTM digital elevation model. Here you can see the results. I compared the mean velocity of August with the mean slope, mean aspect, and mean height of the sampled areas. Here you can see the mean velocity. And you can see the mean slope, this line, and which is really interesting on this first figure, that we can see that at this slow moving area, the mean slope is increasing really fast, which is a strange and interesting phenomenon, because we thought that if the mean slope is higher, then the glaciers moving faster, but we see the opposite of this phenomenon. And on the second figure, we can see the mean velocity and mean aspect, but exactly they were not much correlation between these two parameters. On the third figure, you can see the mean velocity and mean height, which is interesting that the low altitudes area are the fastest areas of the glacier, and the high altitudes are much slower than the others. And we can also see at this slow moving area that the mean height is increasing really fast. I also have ice thickness and bed elevation data to the sampled areas, but are based on gravity data and radar measurements. So I compared the mean velocity and the mean ice thickness. And here we can also see some interesting thing, that these slow moving area at this part of the glacier, the mean ice thickness is decreasing really fast. And also at this slow moving area, we see that the mean bed elevation is increasing really fast. So it is really interesting. And now I would like to show you the seasonality of the velocity, because the velocity varies a lot from the front of the glacier to the accumulation area. Here on the first picture, you can see the Hoarhamont 1 and 2 sampled areas, which is here at the front of the glacier. And you can see a really strong fluctuation in the velocity. This can cause because of calving. So we can say that these 2 kilometers is the calving zone of the glacier. On the second figure, you can see a much more stable zone. We also see some fluctuation in the velocity, but it's almost the same at all the sampled areas, but it's not so high if we are farther from the front of the glacier. And the third figure is really interesting, because at the 12th and the 13th sampled area, we can see a really strong decline in the velocity. So this could be the boundary of the ablation and the accumulation zone of the glacier, which is really interesting for us. And for the last figure, you can see the accumulation zone of the glacier. Here is the 16th sampled area, where we can see some fluctuation, but all the other measurements is just sporadically on the area of the glacier. So this should be the accumulation zone. And some summary. So the relationship between the velocity and the topography. The fastest moving areas at low altitudes, but this is not a big surprise, because at low altitudes the temperature is higher as well. And we saw that as the mean slope increases, the velocity decreases. This was a really interesting phenomenon. And we also saw that as the thickness of the ice decreases, the velocity is also decreases. This is also interesting information about the glacier. And we could well distinguish each zone of the glacier by examining the velocity. So we could distinguish the calving zone, the stable zone, the accumulation zone, and also maybe the ablation and accumulation zone border. And to say something about the condition of the glacier, we need to do more research. We need to examine longer period. But if we compared our result to the previous results, we can see something really interesting. This figure is Maginot and Rignaud figure, whom investigate the velocity of Glacier Hoarhamont from 1984 to 2014. And if we put our result, so the 2020 year velocity, mean velocity of the Hoarhamont, we can see that this part of the glacier, whether it was really fast in Maginot and Rignaud research. In our research, there is a stronger change at this part. We can see it's really slow at this part. At this moment, we don't know what caused this phenomenon, but we would like to find it in the future. And to the end, I just brought a short video which showed the glacier Jorge-Montt's front. You can see the velocity and the retreat of the glacier in 2010. And this is made with the stop motion technique, but it's really good to show you that how fast is this glacier, not just on the satellite images. And last but not least, thank you for your attention.